So I'm Ian Craggs. I work for IBM on the Watson IoT platform, and I'm also the co-leader of the Eclipse PAHO project, which develops client libraries for MQTT and MQTT-SN, and some other utilities as well. I've worked with MQTT since the early 2000s, and in the Eclipse PAHO project, I maintain the C client, the embedded C client, the embedded MQTT-SN client, and the MQTT test material. So I'm just going to ask the question, why do we need a new version of MQTT to start with? Because 3.1.1 hasn't been out for too long. The standardization was completed in 2014. So I was a member of the standardization committee at the time, and there was a discussion about whether we wanted to proceed with a new version right away or leave it for a good few years. That there was a balance between not wanting to disrupt people who are already or just about implementing 3.1.1 and leaving it too long so that it appeared that there was no activity on the technical committee. So I'm not sure whether we're going to be pleasing everybody. I'm sure there's going to be some people who are unhappy that we have come out with a new version. But the important message that I'm thinking, is, from my point of view, is that we're not deprecating 3.1.1. We're providing a new version with new capabilities that has some extra features. But because we've got extra features in there, it means that there's extra work to implement it. There are some features to minimize that extra work, but 3.1.1 and 5.0 may well be complementary. And I think they'll coexist for a long time. These are some of the original design goals from 1998 for MQTT, and you'll see that a large number of clients in 1998 was 10,000. Actually, I remember one of the early versions of the specification which said that 50 clients for an MQTT broker was a reasonable aim to start with, but that was a long time ago. So you can see it's been around for a long time. It was originated as a very practical solution to the problem of monitoring the state of an oil pipeline across Alaska. So they wanted to make sure there weren't any oil leaks along this 2,000-mile or whatever distance pipeline, and they had sensors all along the pipeline to measure the pressure, to make sure there weren't any pressure drops. And at the time, the solution involved polling. MQTT was developed as a practical solution to avoid that polling problem, and it's developed from there as a practical solution. It's not theoretically nice or anything like that. It's a practical solution. And as a result of that practical focus, there are some things that people would like to fix. This is just an indication from the Eclipse IoT workgroup statistics about the popularity of MQTT. It's not scientific, it's just the number of visitors to the websites. The top two on the chart are Mosquito and PAHO, which are both MQTT projects. As I said, you shouldn't read too much of it into this. It's just a vague indication of the relative popularity of MQTT. And the downloads figures show the same thing. But people get all of this software from all sorts of sources. So this is a very gross generalization. And it's nice to see Californium up there as well. Second on that list is an implementation of CoAP. If none of you know about what CoAP is, you should take a look at that, because that's a technology that's complementary to MQTT, I think. So this is an excerpt from the charter for the 3.1.1 standardization process. And because MQTT 3.1.1 MQTT had been around for a long time, but it hadn't been standardized, the goal of that standardization process was to get something out quickly with a minimum of changes, so that the existing implementations wouldn't have to undergo drastic refactoring. So we were only allowed to change the connect packet, none of the other packets, no publish, no subscribe, anything like that. That meant that we were able to get standardization done within 18 months, but it also meant there were a lot of things that people really wanted to fix that we weren't allowed to fix in 3.1.1. Top of that list is poor error reporting. For many of the commands in MQTT, there was no way of sending back a message saying, yeah, you got that wrong, and this is what you've got wrong. We did fix one thing in 3.1.1 that you were allowed on a subscribe to send a negative acknowledgement back, but that was because there's some spare bits available in the subac packet, which we reused for that purpose. But we couldn't do that for publish, which meant that the only option for a server, if you send a publish command, send a message to the server and didn't like it for whatever reason, was to ignore it or drop your connection. And there are a number of examples of people trying out new servers or new implementations, finding that their connection is dropped, not getting any information back, and going, and having to go over to the server and figure out what went wrong. So we wanted to fix that. Properties, message properties, and metadata on messages, that's been a suggestion for many people over the years, so we've added that. And for very large-scale implementations, requiring state to be held across sessions is something that can cause a problem. So it's okay if you've got thousands of connected clients, but when you start talking about millions or billions of connected clients for a cloud service, and they can connect to a number of endpoints, if you have to store that state when the connection is broken, that can be a big issue. So we have added the ability for servers to explicitly support some features and not others, and be able to report that to client applications, so they're not in the dark when something doesn't work. So where are we with MQTT v5 at the moment? It started by changing that charter that you saw, so something that was enabled us to change basically anything in the protocol. So these were the collection of ideas that we started with. Error reporting, enhancements for large-scale systems and scalability, metadata, the properties, and a catch-all bucket at the bottom, some added support for the Arduino clients and performance improvements. As a result of that, we ended up with a new charter which has got a few corresponding paragraphs to those big ideas listed in it, but it basically enabled us to do whatever we wanted. And at this point, the large number of people of IBM on the TC were joined by a few members of Microsoft, including a new co-chair, and that process of having Microsoft involved has been very helpful, as well as some other MQTT vendors like DC Square and Cumulosity. So, as I said, cooperating with Microsoft on this has been really helpful. This is where we are in the process of getting MQTT out. One of my colleagues looked at my fancy new timeline and said, timelines don't go this direction, they always go from bottom left to top right, but there you go, I was trying to get something a bit different. We started off in the first quarter of 2016 with a new charter. Between then and now, we've had 15 working drafts, and the first public review draft was made available in August. We've just finished that first review period. There have been a good few comments on that review draft, both from members of the committee and from outside, so that's great. So the next process will be we're going to refactor, or look at those comments, refactor them into the second review draft. That'll be coming out, I anticipate, in a few weeks' time, and that'll be another 30-day review period. If there are no comments, or everybody's satisfied with that, then that will go into the final part of the process, and we might get a new standard publicised in the first quarter of 2018. If there are still comments on that second review draft, then it'll go into another review period. We'll keep iterating that until everybody's satisfied. So it may take longer than that, but I think that the co-chairs are hoping that it's going to be the first quarter of next year. So if any of you have comments about this standard or questions about it, unclear about it, then, and you would like to affect changes, then now is the time to do it. Get it in, get your comments in the next review draft, which will be a 30-day period, hopefully starting in a few weeks' time. Look at the MQTT comments list or on Twitter for the MQTT Eclipse people who will publicize the upcoming dates for that. This is what the review draft looks like, and as I said, there may only be one more cycle of this, so be sure to get your comments in that cycle. So some of the new features, this is how those big ideas were split into particular issues. I'm not going to go through them in detail because I don't have enough time for that, but I'm happy to talk about any of these afterwards throughout the next few days, because there's a lot of detail behind each of these issues. I will go through a few of them in a couple of slides' time. You'll see that some of these issues didn't make it, or have been transformed into other things. This is one of the example of an issue that didn't make it, the support for large message transmission. So it was suggested that we might have some facilities to automatically break up large messages into smaller packets. And as with all of the issues or all of the concerns that people raised, we were thinking, well, how necessary is it to do that? Because each feature we add is going to add to the complexity of the protocol. Splitting up large messages into smaller packets, smaller pieces, is something that people can do in applications, so we felt we didn't need to add it to the protocol itself. So that's one thing that didn't make it. As a result of all those changes, these are the packets that existed in 3.1.1, and the only new one we added was an authorization packet for challenge response authentication. This is an optional feature to increase the security of the protocol. So we've only got one new packet. All the rest of the packets are the same as previously. But all the packets have properties now added to them. So there's a lot of features in those properties that are added to a consistent way to all of the packets. And a couple of those properties are reason codes and diagnostic error messages, which can be added to the acknowledgement messages, so that whenever something goes wrong, from the server or client can communicate that reason back to the receiving end, which wasn't possible in the previous versions of MQTT, which I think is a big benefit. So these are some examples of the properties on the Connect. In fact, this is the complete list of properties on the Connect. So we have a session expiry interval. We have the ability for the client to say, for instance, the maximum packet size it's willing to accept. So previously, if you had an Arduino which had 16K of memory and it could only ever hope to process a maximum message of 256 bytes or something like that, if the server received a 100 meg message for it, then it would try and send that 100 meg message, and the Arduino would probably fall over, the connection would drop, and then when the connection restarted, maybe the server would try that all over again, and you'd end up in a pretty messy loop. This way, the server can say, oh, well, that device has no chance of receiving or processing that message, so I'm not going to even try to send it to it, and I can put out an administration message and inform the writer of the application that they need to fix that sort of issue. As I've got 5 minutes left, I'm not going to go through any of these others, but just to say, let's see. The session state has been simplified. The session state lifecycle. So in 3.1.1, there's a clean session flag on a Connect for a device. That had the feature of erasing the session state both at the beginning of the session and the end of the session. Now we have a more flexible ability to own the clean state at the beginning of the session with the clean start flag, And then there's a separate session expiry property, which enables you to say, do I want this session to be cleaned up at the end or not, or after some period of time. So if you have a device which reconnects within the session expiry time, that session state is still going to be available. This provides a much more flexible way of cleaning state and managing it, both from the client and the server end. Product properties, I don't have time to go through that. If you want to ask me about any of these things, then please do come and talk to me afterwards. On the publish, I will mention that we've got the ability to add content types so that you can provide an indication of the format of the data within that payload. This is, in 5.0, it's a lot easier to simplify, to clean the old session state and preserve the new session state that you create during that session. As I said earlier, I think my view is that 3.1.1 is not deprecated, that V5 and 3.1.1 will coexist for a long time, not least because people implement devices and put them in the ground or in remote stations, and they're going to have a long lifetime. For after V5, once we've completed the V5 specification, I don't envisage that we'll produce a new version anytime soon, but we may look at applying MQTT to non-TCP transports like UDP and ZigBee, for which there is already a specification called MQTT-SN, but it's not a standard, so we may well look into doing that. And in Eclipse, there's already some test material in the Eclipse PAHO project. I'm thinking about collaborating with the Eclipse IoT Testware project, which is developing a standard 3.1.1 test suite, so if we can extend that to 5.0 as well. And my colleague James is developing a Java client and has already used this test material in that process. I'll be developing the C and embedded C clients, and using this test material, there's already been a pull request submitted to Mosquito for serializing and deserializing V5 packets. So I'll just show you a little bit about what the test material looks like. Just let me get out of that. That's the Eclipse IoT Testware project. So the PAHO testing project has a means of starting a V5 broker. This is all written in Python, so you can go and see the code. The broker, the client library, and the unit tests are all written in Python. And I'll just start the broker. You see it starts with some listing of optional behaviors. So this allows you to set different characteristics of MQTT. When you implement a production server, normally you would choose one thing or the other. But I've chosen to make these behaviors optional so we can test as many of them as possible. And then I can run this unit test. Yep, I've got 1 minute left, so I'll just run the unit test. And it's not going to display much at this point, but I'll just go back to the broker to show you. So these are the V5 packets being sent back and forth. And I'm just going to stop it at this point as it runs through there, because what I want to show you, or to just mention, is that within the broker, throughout the specification, there are conformance statements which say that the server or the client must do this, must do that. I've embedded those conformance statements within this server so that when you run a test against it, or you run your client library against it, it will tell you how many of these conformance statements you've met. So the goal is for a complete test suite that you would cover all of these, you would exercise all of these conformance statements. I only run a small amount of the test suite at the moment, so it's only reached a small amount of coverage. But that, in addition to code coverage for the test server, I've envisaged that as a goal for your testing, for your client libraries or your servers. So this allows you to, if you're developing a client library, you can use this test broker to communicate with, and as an implementation and test aid. If you're developing a server, you can compare the behavior of your server against this test server. So this is there to help everybody with their V5 implementations. And that's all I have to say now. I'm running out of time. Thanks very much.